Today we are going to study why 0.99999 infinite number of 9 is 1. We start with a function. Let me recap what's a function. Function is a relation. What is a relation? It's some specific Cartesian product. What is Cartesian product? Some special set. What is set? Some logic thing. Done. And now we are going to focus on this domain is natural number 1, 2, 3, 4, 5 and so on. And this is what? We call it a sequence. We write AN. So basically A1, A2, A3, A4. So for example, this is a sequence. And Fibonacci sequence 1, 1, 2, 3 something is also a sequence. You may not know this kind of sequence have a formula. Looks like this. This is called golden ratio. You don't need to know where the heck this comes from. Doesn't matter. Basically, the idea is that if you have a sequence, you have two ways to write down. Number one, you write down the element like a set. You write down what is inside the set. Number two, you write down a formula of the set like this. So this is the formula of Fibonacci sequence. Now, suppose I have a sequence AN. Today's goal is to understand this big chunk of thing. The limit of a sequence AN, n go to infinity, equal to a number. This number I call it the limit. And because limit starts with letter L, so I write L. I'm saying this. That means what? I'm just saying this is a thing. I didn't define what does it mean. It means this big chunk of thing. Oh my gosh, what the heck? You have three brackets. First bracket, second bracket, third bracket. You may read from the left to the right. No, read from the right to the left. It means what? I have a sequence AN near L. So this part in blue means my sequence near L. Near is an adjective. It's not precise. 1 meter is near. 1,000 meter can also consider near if you are talking about shooting a missile. Okay? So you need a number to describe what does near mean. So we have an epsilon. What does it mean near? You have two numbers, subtract each other, and it's smaller than epsilon. That's it. And since you're talking about distance is not negative. So you take absolute value. I just said the absolute distance between these two numbers is near. How near? Smaller than epsilon. So this is the meaning. What the heck is this part? This means I'm not talking about any n. I'm talking about all the n after this big N. Then this is the first bracket. What is this second bracket? Second bracket means there exists a big N in natural number such that this is true. Okay, then what is the first bracket? The first bracket is for any epsilon larger than 0, this big chunk of thing is true. So how do you read it? For any epsilon larger than 0, there exists an n in natural number such that if small n larger than n, then it implies an near L. Let's say I have a sequence like this. Well, this guy getting smaller, 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 and smaller. So we will say this limit go to 0. So L is 0. The big L is 0. So we are saying that the limit of this for n go to infinity is 0. So here's how you prove this. You assume there are two people arguing with each other. In the 0.99999 situation, some people will say, no, 0.99999 is not 1. It's always slightly smaller than 1. There's some small gap there. This epsilon is the gap. So the whole story is that, let's say I argue with you. I say this limit go to L. What I'm doing here is that from whatever challenge from you, I can resolve it. Then I win. This is the meaning of this whole chunk of thing. So this part is from you. You are saying, I don't believe you. There should be a gap, which is very small. So that's why it's larger than 0. It can be any number. It means a gap. And it gap is from you. You don't believe me. You said, no, I believe there's a gap between the sequence and the L. So you give me an epsilon. What I'm going to do? I'm going to do is that, okay, I consider your epsilon. I resolve your issue by saying this big chunk of thing. What is this big chunk of thing? It's saying that, so what is this AN? This AN is just a bunch of numbers. I'm saying there is a big N. Imagine it's like I have a cut. I cut like this. What does this N larger than N means? N larger than N means after the cut, right? Then what the heck is this thing? This means after the cut, all the number here is near, under your challenge. That means you say this converges to this number. I don't believe you. There should be a gap. Then I say, okay, with respect to your gap, I can always find a cut. Everything after this cut is smaller than your gap. Then I win. And I need to do this for any challenge you give me. If I can beat any challenge you give me, I win all the argument. Then I win. This is how you prove a limit is L. This is the idea. So that means what? You will have two people arguing each other. They will have countably infinite argument. And one side will give countably infinite or even uncountably infinite many of challenge. The other side basically is that, okay, for whatever challenge you give me, I can always resolve it. And since I can resolve any challenge you give me, then you lose, I win. This is the idea. Okay, this bunch of things is just what I said. Read it by yourself. Let's now go into practice. How do you prove this? Maybe you have argued with people about high school or primary school that 0.9999 is not 1. Now I'm going to argue. No, it's 1. How do I prove it? I need to first write down a what? A sequence. So I am going to write 0.999 thing as this thing. What's this? The first number is 0.9, which is 1 minus 0.1. And then the second is 0.99. So every time I add one digit, basically I just doing this, right? I'm going to prove this thing converts to 1. So what's the definition? I need to write this big chunk of thing, right? And I said, go from here. So I look at here first. AN minus L. What's my AN? This is my AN. So this is my AN, right? So I replace this by my AN. And now this is my L. This is my L. This is my L. So from here to here, I just copy and paste. So this part is just this part. And I also have the epsilon, I just copy here. Okay, so what does it mean? It means you give me an epsilon, I need to find the n that this is true. So I'm working backward. So now I have this yellow part. Now mathematics, 1 and 1 cancel out, so there's no 1. And then absolute value cancel the negative sign, so I now have this yellow box. Okay, then what's next? Now I have this. So basically from here to here is I simplify the expression. Now I want to find a big N thing. The idea is find the big N such that this is true for whatever N after big N. So that means I want to find what's the expression of small n. So I will try to write small n as a function of epsilon. So first I will what? I put this here and put this out, so I have this and I flip the inequality sign. I have this expression. With this, you take log, and I'm going to take base 10. So I take base 10. This guy is just 1, so there's just n here. And this is negative, that's why you have a negative number here, okay? But anyway, so now you have this kind of thing. Now, this is the big N. Why? Suppose you say that, no, 0.999 is not 1. I give you a gap. The gap is 0.01. Then from this expression, I can say that, okay, if this is your gap, then I say that after n equal to 2, anybody after the second location is always smaller than your gap. That means this kind of number towards my L, smaller than your gap. Then I break your argument. And then let's say you say that, no, okay, now I'll give you a smaller gap. This gap is 0.001. It's fine. I found that after the third box in the sequence, all this number will have a difference with one smaller than your epsilon. So that means what? No matter what kind of epsilon you give me, I can always find a bunch of AN. The gap between this AN to 1 is smaller than your gap. Then I win. First of all this is if and only if, right? So that means if this is true, because these are all if and only if, then this is true, right? This part means what? Sequence gap smaller than epsilon, right? So this means I beat you. What is this? This is an expression on small n. This is expressing small n as something on epsilon. So you can just take big N as the nearest integer of this guy. So this is how you get the big N. If I have epsilon 0.01, I log this base 10, it gives me negative 2. But I have a negative beforehand, it gives me positive 2. This is my N. So that means what? This guy actually give you an expression when this will be true, then this guy is also the N. But it's possible this guy is not integer. So that's why your N actually need to do something after this step. I will show you an example later. Okay, so that's how you get the big N. Let's recap the whole story. Here are the 3 steps. Write down this. This means I beat your disagreement. Then I need to show this, right? So I have to work on the math to show this is true. I work backward to find the big N. So I try to simplify this and then write down small n as a function of epsilon. And since this is wrong, I want big N. So big N is a natural number, so I need to use ceiling in the end. Okay, spelling mistake. So that is, how do I find this big N? I look at what are the relationships between the small n and your gap, and then I find the big N. So let me recap from the very beginning. I said an limit go to infinity is L. You challenge me by saying that no, there's always a gap. That means this thing. What I'm going to do, saying that there exists a big N, anything after this big N, this is true. Your disagreement is false. I'm going to now explain this part. Let's imagine I have a sequence that keeps going down, and let's say this sequence is exactly this guy. This guy converges to 0. So that means I'm saying in the end it will converge to 0. That means the y-axis here is 0. So my L is 0. Okay? So what in this case was the gap? The gap basically is the distance between the dot and the x-axis, right? So basically it's saying that you have a disagreement. You say that there will be a gap. Why? Because you disagree, there is 0. So you say that there is always some tiny space between the point and the line. But here's the important thing, I'm saying that you're true, but I'm considering at infinity. So I just need to say that after a certain point, anything here, the gap between this point to the x-axis is smaller than your challenge, your gap. And it's true. This is important. That means I'm not talking about the whole sequence. I'm talking about part of the sequence. This part of the sequence is exactly this thing. What's this? I'm talking about all the n larger than big N. So it's possible A1, the gap is bigger than what you mentioned. It doesn't matter. Why? Because limit only look at in the end. It does not care about in the beginning. This is why you write this thing. So it's saying the behavior in the end. In the end means in the infinity. In the infinity means everything here. Countably infinite term here. Everything here has to be true. So what I'm saying is that for all the n larger than this particular guy, how many number here? Countable infinite number of terms. That means infinite number of them. This is true. And I have all the thing after this particular cutting point that I disprove your challenge. Then it's correct. Because we are now talking about in the end. This guy, the gap is too big, doesn't matter. And if you give me a gap that is extremely small, it's very possible. Then the cut will occur here. Doesn't matter. The main point is, I don't care where is the cut. I'm saying the cut exists. It can be a cut that the number is extremely big, even more than the number of particles in the universe. It's fine. We're talking about logic. It exists, then it exists. Okay? So it's possible you give me an extremely small gap. That means this guy is 0.00000 many zero, let's say 1 trillion zero. I can still find u and n. That everything after this n, all the sequence have smaller gap than your input. Since we are now talking about infinity, countable infinite, we can always do this. Now you should understand why last time we talked about infinity. Let me recap. Two people are arguing. One claimed that this is true. The other guy disagree. The one who claimed it fight back. That's it. How do I prove this is true? I prove this true by first writing this as a sequence, an. Then I'm saying I prove this is true by saying this sequence limit is 1. So I need to prove this long chunk of thing. Work from the back. So I first start with this. This is what I said. Write down this expression. This is what I did. And then what? Step 2, simplify the math. Remove redundant thing. So 1 and 1 cancel each other. Give me this. Absolute value kills the negative sign. So it gives me this. And since this part is always larger than 0, so I also don't need absolute value. Okay? So I have this. Then what? I want to find big N. Big N will be something on small n. So first I find small n. So this gives me small n. And here all if and only if. What does it mean? That means if n fulfill this condition, this is true. Then I just let big N is this number. Done. But it's possible this is not an integer. So this guy, the closest integer of my log epsilon,